Hello friends. So in the previous video we discussed about the basic introductory concepts related to vector product or cross product, that is uh, how two vectors are multiplied in the form of cross product or vector product, and what is the magnitude and direction of the resultant. So we use right hand thumb rule to determine the direction, and the magnitude we also discussed that. So there we just got to know that if there are two vectors, let's say, okay, let's say this is B vector and this is A vector, and in this case the direction is like this, from theta is from A vector to B vector. It is represented as A vector cross B vector, and the direction of the resultant, it is mutually perpendicular to the plane containing the two vectors. It is like this. So C vector magnitude is AB sine theta, and this is the direction. And if the opposite thing happens, that is, this is B vector, this is A vector, and the direction is opposite here and like this. So in that case the vector, let's say C dash vector, is B vector cross A vector, and here the direction will be opposite in this way. Okay, magnitude will stay the same, that is C dash vector magnitude will also be A B sine theta, only direction will be reversed. So now we'll be discussing some properties of cross product or vector product. Okay, now we know that the vector product, its magnitude, it is given by A B sine theta. Okay, so when theta will be 90 degree, that is A vector and B vector, they are perpendicular to each other. Okay, in that case the magnitude C vector will be A B sine 90 degree. Now we know sine 90 degree is equal to 1, so it will be A B. Okay, so this is for perpendicular vectors. Then another important property, which is for parallel and anti-parallel vectors. Okay, let us say we have two vectors, A vector and this is B vector. They are parallel and they are in the same direction. So in this case theta will be 0 degree. This is called as parallel vectors. Another situation where, let's say we have two vectors, this is A vector and this is B vector. They are parallel but in the opposite direction. In this case theta will be 180 degree. So this is called as anti-parallel vectors. So in both the cases the vector product or cross product, okay, the vector product or cross product magnitude will be AB sine 0 degree, which is equal to AB sine 180 degree, which is equal to 0. Okay, the magnitude, it will be 0 for parallel or anti-parallel vectors. Okay, another interesting thing. Okay, now we know that as per let's go here to explain the third law. Now we know that when it comes to cross product, and we emphasized that point in the previous video also, the order in which the vectors are multiplied, that is very important. Okay, so here in this case, a vector cross b vector, here a vector is the first vector. Okay, let's use the red one. Okay, a vector is the first vector, b vector is the second vector. Sorry. Now the direction of the angle theta is from a vector to b vector, as if it is trying to rotate a vector in the direction of b vector, into b vector. So that's why, as per the right hand thumb rule, we have already discussed it in the first case, in the first video, so I will not repeat it again. So as per the right hand thumb rule, the direction of the extended thumb gives us the resultant vector, which is upwards. Okay, but in the second case, b vector cross a vector, this is the first vector, this is the second vector, and the direction of the angle theta is from b vector to a vector, as if it is trying to rotate b vector into a vector. So in that case, the thumb points downwards, just the opposite of the first one, and this gives us the resultant. In both the cases, magnitude is same, direction is opposite, and hence the property that a vector cross b vector is not equal to b vector cross a vector. The magnitude is same, but direction is opposite, so that's why they are not equal. Actually, it is a vector cross b vector is the opposite of b vector cross a vector, or we can say c vector is minus c dash vector. This is c dash vector, this is c vector, so it is minus c dash vector. So the property, we can specify it as cross product or vector product. This is the third property. It does not obey commutative law. Okay, they do not obey commutative law, which is clear from this. Okay, so 1, 2, 3, next. Okay. Again to black. Okay, fourth property. Now suppose we try to find the cross product of a vector with itself. Okay, with itself. So what is the definition of cross product? It is, if there are two vectors a and b, it is a b sine theta, the angle between the two vectors. Now here both the vectors, they are the same, and the angle between them is 0, so it will be a vector cross a vector, that will be a into sine 0 degree, which is a square into 0, which is equal to 0. So from this we can conclude that the cross product or vector product of any vector with itself is 0. Okay, this. So this is the fourth property. Next is the fifth property. The fifth property says that cross product or vector product, it obeys distributive law. Okay, it obeys distributive law. That is, A vector cross B vector plus C vector is equal to A vector cross B vector plus A vector cross C vector. This is the distributive law, and cross product or vector product, it obeys distributive law. It does not obey commutative law. Okay, cross product does not obey commutative law, but it obeys distributive law. Okay, so these are some of the important properties related to cross product or vector product. Okay.